Okay, everybody. So today we're going to be learning about comparing fractions. But before we get to that, what I'd like to do is I'm going to show you some problems where I'm just going to want you to identify these fractions really quickly. So let me go ahead and share my screen with all of you. And we'll get to it. I want you to take your whiteboards, work these out, and then you're going to put them in chat. And what we're going to do is we're going to waterfall. Okay, everybody, we're going to waterfall for these. So we have the fractions here up on the screen. I want you to do the first one, the one that's the pinkish color first. Okay. Do the pinkish color first. Go ahead and identify that fraction. If you need to write down on your whiteboard, write down on your whiteboard. If you can just figure it out. And then put it into the chat, but don't send it yet. We're going to use the waterfall technique today. I'm going to give you about 20 seconds, and then we're going to go ahead and waterfall. And waterfall. Go ahead and send them in chat. Thank you, everybody. We have 1 over 2, 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 1 over 2. Good. And everybody remembered that we use the slash to show that is a fraction when we're typing it into chat. So, yes, this one is 1 over 2, or 1/2. Now I'm going to go ahead and have you do the green one. Go ahead and do the green one. Same thing. I'm going to give you about 30 seconds to identify that. This time, instead of waterfalling, I'm going to, Tristan, not yet, I'm going to call on a name right here. And that person is going to help me out with the green one. About 10 seconds, and now we are going to mix these all around and select one name at random, and we got Jasleen. Jasleen, go ahead. The green one. What fraction is that? Thank you, Justin. So there's 5 total and 4 are shaded, which makes it 4/5. Thank you. Next, we are going to go ahead and move on to the purplish one. For the purplish one, we're going to go back to using the waterfall. Excuse me. Part of it might be a little confusing, so I'm going to go ahead and move a line right here so that it's easier to identify. So when you are ready, or when I am ready, I will say waterfall, and we will go ahead and share those into the chat. We've got about 15 seconds, everybody. And waterfall. Good. Very good, everybody. 8/10, 8/10, 8/10, 8/10, 8/10. You could not tell by now, it is, in fact, 8/10. It is 8/10. Great job, everyone. And the last one. This time I am not going to put in the lines. Let's see if you can figure this out with these little lines on the bottom. We're going to go ahead and I'm going to pick another volunteer. But I'm going to give you about 20 seconds again. Yeah. Do you, if you want, you can go ahead and be the one to say it, Damien. Say that one more time. 3/7. Well, let's make sure, okay? Let's double check. So let's add some lines. Because we didn't add the lines because we thought, well, let's make it a little tougher. So let me add these lines in. And we'll see. Because it was a little hard to count, I will admit, without these lines. So let's count them. I'm going to go ahead and take my pencil. My pencil tool, make it. Oops. Can I erase that piece? Take my pencil tool, make it nice and again, make it nice and skinny. I'm going to count these up. 1, 2, 3, 4, 5, 6, 7, 8. Very close, Damien. Like I said, it was a little bit harder to count because we didn't have the lines there. But it is 3 shaded out of 8 total, which we have established will make it 3/8. Now, an important question I want to ask all of you is this. Just looking at these fractions, can you tell which ones are bigger? Give me a thumbs up if you can. Just by looking at them, you can tell which ones are bigger. Let me see some thumbs ups. So if you were to look at these, which one is the smallest and which one is the biggest? Go ahead. Any volunteer want to help us out? Which one is the smallest and which one is the biggest? Go ahead, Emma. So the smallest you have as 3/8 and the biggest is 1/2. Does anybody disagree with that, or does anybody have a different answer? Because I'm not talking about the individual pieces. We're talking about how far the shaded part goes. So if we look at this one, the shaded part goes to here. The green one, the shaded part goes to here. The purple one, the shaded part goes to here. Oops. And the blue part, the shaded part goes to here. So she is correct saying that 3/8 is the smallest one, but 1/2 is not quite the biggest one. Go ahead. The 8/10. Yeah, so you see the 8/10 goes here, and so does the 4/5, which is farther than the 1/2 goes. These go farther, which means they are bigger. They are a bigger part of one whole, because remember, each one of these is one whole. So that was kind of a quick review to get us prepared and get our minds ready for what we're going to do now, which is we are going to learn about comparing fractions using a benchmark. So first we start with our essential question. How can you use benchmarks to compare a fraction? Well, there's probably a little confusion there, right? Because we haven't talked about that word, have we? Benchmarks. We haven't talked about benchmarks. And now if we look at our objective for today, you can use benchmarks to compare fractions. Well, again, have we really talked about the word benchmarks? Have we heard that word before? Well, we're going to learn what it means today. So I want everybody to take about 30 seconds, and I want you to come up with your best prediction or guess for what the word benchmarks might mean. What does it mean? How? How do you think it applies to comparing fractions? What do you think before we go a little deeper? Yes. That's very close. That's they sound similar, but I think you're thinking of a bookmark. Yeah. Bookmark and benchmark do sound a little similar, but they're not quite the same thing. So while you're thinking of that, I just need to move this one down a little bit. Okay. And we are ready. What do you think a benchmark is? I'm going to select 2 non-volunteers who are going to help us out. Remember, this is your best prediction. I don't expect this to be the right answer. It's just what do you think it might be? Victor, go ahead.
Like the lines on a fraction and you put them together.
Okay, like the lines on a fraction, you put them together. Okay. And we will select 1 non-volunteer, which we have Camila. What do you think?
That it maybe like puts like a little line or something.
Okay. Maybe like it puts a little line. I'm going to tell you. A benchmark is, we'll call it a number. A benchmark is a number that stays consistent, or it stays the same so that we can use it to compare other numbers to. Let me move this. A number that stays consistent so we can compare other numbers to it. That might sound a little bit complicated, but it's not. Once we explain it and we go through it, we should be able to understand it. So we're going to use this problem right here to help us understand it. David made a popcorn snack. He mixed 5/8 gallons of popcorn with 1/2 gallons of dried apple rings. Did he use more dried apple rings or more popcorn? Well, like we've talked about before with word problems, the first thing that we need to do is, what is the problem asking us to do? So that we know what we should do in our next step. So what is this problem asking us to do? Go ahead and help me out. Luciano, what is our problem asking us to do? When we look at this problem and we give it a quick read through, what does it want us to do?
Is asking us to do asking us to do
Anyone want to help Luciano out real quick? Destiny, go ahead.
It's asking us if David used more dried apple rings or more popcorn.
So it's asking us, did David use more dried apple rings or more popcorn? Which, the kind of problem that is given to us is right here. That's our secret. Did he use more dried apple rings or more popcorn? Dried apple rings or more popcorn is telling us that we need to compare them. We need to compare the amounts that he used. And we have the amounts up here. So he mixed 5/8 gallons of popcorn with 1/2 gallon of dried apples. So I already made these two little fraction strips that we can use. So I'm going to go ahead and say right here in yellow, popcorn, because this is the popcorn. And I'm going to use red right here because it's apples. And here we have our dried apple rings. And now it's asking us, or it's telling us how much of each he used. So for our dried apple rings, if it says he used 1/2 gallon of dried apple rings, how much of that fraction should be filled in? How many of those rectangles should I fill in? How many units should I fill in? Go ahead and type it in chat, and we will waterfall in about 20 seconds. We will waterfall in about 20 seconds. Five, 4, 3, 2, 1, and waterfall. Okay, we have 1, 1, 1, 1, 1. Exactly, because it is 1 out of 2 or 1/2, we will fill in one of these. One of these needs to be filled in. I know it's not perfect, sorry everybody. But you see, you get what I'm going for. Now for our popcorn. Now we have our popcorn. How many of the popcorn should I fill out? And everyone, quick on the draw. Exactly, 5. 5. We should fill out 5 of the popcorn. All right. So there we go. We have 5 of the popcorn filled out and the dried apple rings filled out. Which one did he use more of? Can you tell already, just based on the pictures alone, we'll waterfall it, which one he used more of? I'll give you 15 seconds. Just based on the pictures alone. Can we tell what he used more of? And waterfall. Thank you, everyone. The popcorn. We can tell just by the pictures. We can see, I'm going to use the color blue here, that the dried apple rings only go up to about here, while the popcorn goes up to here. Look, which has the bigger line? The popcorn does. The popcorn is more. And we know this because, remember, with the fractions, this part that I'm going to outline right here in green, for both fractions, this is one whole. Even if the pieces we are using are different. Remember, like we were talking about yesterday with the pizzas and the tortillas, and we took them and we cut them into different pieces? Even though we cut them into different size pieces, the pizzas and the tortillas were all the same size in the end. So just doing that, we're able to do our comparison and tell that the popcorn is bigger. And the popcorn's fraction was 5/8, while the dried apples was 1/2. So which one is bigger? We already said 5/8, which, we'll go over this again. I want to quickly show you 3 strategies for how to fill this out. Strategy 1 is you know what the shapes are. That this means greater than or less than. Thank you, Chase, for sending it in chat. Here is another strategy. You've probably heard this one before, but the alligator will always eat the bigger number. You've heard that before, right? And one more that I was taught by my mom is the side that has the bigger number, you're going to put 2 dots. The side with the smaller number, you're going to put 1 dot. And then you're going to connect the dots to make a V. Okay, so if you don't remember how to do the comparisons, you can use those very quickly to help you do them. Now we're talking about equivalence because we just used the number 1/2. Right? We used the number 1/2 right here. And we're talking about equivalence because, let me grab a different color. This is the same as this. Remember, Equivalent fractions. So just looking at that, what is the equivalent fraction to 1/2 that uses eighths? I'm going to want you to waterfall this one, okay? I'm going to go ahead and we're going to skip this question for the sake of time. Alright, and we're going to go to this. Like I said, how many eighths are equivalent to 1/2? Go ahead and waterfall that. We drew that right up here. If anything, I will copy that down so that we can have that over with us. How many eighths are equivalent to 1/2? How many eighths do we have? That is the same as 1/2. If you need assistance, let's go ahead and we'll do it slow. So we have 1/2 right here. Here's our 1/2. Okay? We have our 1/2 right here. And then we have our eighths down here. How many of these eighths are the same as 1/2? How many of these eighths are the same as 1/2? How many of these? Go ahead and send it in chat when you got it. Thank you, Victor. Thank you, everybody. 4, exactly, 4. So 4 of these eighths are equivalent to 1/2. So when you're finding the equivalent fraction for those, you have 1/2 here. And 4/8 here. And those are equivalent. They're the same thing. So now we're going to compare two other numbers. We're going to compare 5/12 and 9/10 really quickly. And this one is going to be mostly you. It's going to be led by you. So the first thing we probably need to do is what? We're trying to compare these two numbers. What do we got to do? If we're thinking about how we did it before, using our benchmark fractions, which in this case is 1/2. What do you think we should do? Does anybody want to go ahead and volunteer? If not, I will go ahead and pick a piece of paper. Okay, Victor, go ahead.
First we have to count how many are there.
Okay, so you start. Which fraction do you want to start with? Which fraction do you want to
I
start
didn't
with?
hear.
Which fraction would you like to start with to count? Top or bottom?
The first one.
Okay, this one or this one?
Second.
Okay, so we're going to start here. Let's count them together, everybody. Real simple. We got 1, 2, 3. I want to see everybody counting. 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12. We have 12 there, which means which fraction is that probably referring to? If we have 12 total, it's probably referring to what fraction?
5/12.
5/12. So thank you, Victor. So 5/12. So I'm going to go ahead and select a piece of paper. Whoops, I dropped one. Aiden. Go ahead and tell me how many should we shade in because it is 5/12. How many should we shade in for this one right here?
5.
5. So we're going to go ahead and shade in 5. 1, 2, 3, 4, 5. There we go. We have our 5/12 right here. All right. And then we have the other one, which now we know is the tenths. How many are we going to shade in there? I'm going to go ahead and pick another name. Emma, go ahead.
So it'll be
On this second one right here, how many of this one in this one should we shade in?
9.
9. So let's go ahead and do that. I'm going to move this down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So using the same theory we used before, here we have our benchmark fraction of 1/2, right? We have our benchmark fraction of 1/2 here. Can we tell which one is bigger? Oops. Can we tell which one's bigger just by looking at our benchmark and comparing it to our benchmark?
I know. I know.
It's a little bit hard to hear you, Damien.
You hear me?
It's a little tough to hear. Could you go ahead and type in chat, please? Thank you. Emma, go ahead.
I think I think 9 out of 10 is bigger.
Yes. Does anyone disagree? Give me a thumbs up if you agree. Thumbs down if you disagree. Thumbs up if you agree. Thumbs down if you disagree. So it looks like we have a lot of agree, which, yeah. If we look at here, 9/10 is bigger than 1/2, while 5/12 is smaller than 1/2. So if we just look at it like that, we can make that judgment. We can understand that 9/10 is bigger than 5/12. So when we compare the two, we know that 9/10, well, that's a little ugly. Is the bigger fraction. Okay. The last thing that we're going to be doing today is you will have one that you are going to do on your own. And because I won't always be able to give you a picture, you're going to have to draw your own. So here is your question. I want you to compare these two numbers. Three-fourths and 2/5. And what I will do is I will actually just take one of these. There we go. It looks like my pencil just stopped working. Well, the question is up. My pencil has stopped working, but we do have this here. I'm gonna go ahead and at least try see what I can do about the pencil while all of you start working on this. Remember, use a benchmark fraction to help you figure out which one is the larger one. There we go. I will call waterfall when it is time to share it. I will call waterfall when it is time to share it. And waterfall. 3/4 is bigger, 3/4 is bigger, 3/4. Chase used the symbol for greater than. And I think that everyone is correct, but to make sure, I'm going to go ahead and draw these fractions out. Look at this. So I'm going to draw this, this. The problem when I draw it myself is it's not perfect. However, I do have a website where we can go ahead and use virtual manipulatives. But for now, let's go ahead and fill out our benchmark fraction, which is 1/2. We fill out our first one, which is 3/4, because everyone has sent me in their answers already. We're just kind of clearing this up. And yeah, you can compare it to the benchmark and tell that 3/4 is bigger than 2/5. So I will go ahead and assign everyone your after Zoom work. It's already in there. It's going to be called ISE 6.6. It'll cover this. It'll do a little recap of the video it'll do a little recap video and then it'll give you your assignment. But that is it for the lesson today. Thank you everybody for participating.